Lesson 5.1 has us graphing cubic functions. Within this lesson, we'll look at the cubic function in standard form. We'll also take a look at it written in other forms. A cubic function in standard form is just like a quadratic in standard form. Instead of having an x squared, though, it's going to have an x cubed in it. So we're going to say y equals ax cubed, and then it descends with the exponent, so then it would be a bx squared plus a cx plus a d. So always put your exponents starting off with the highest, the cubic, then the square, then the first degree, and then the no x. All right, so we're going to take a look at what does just the parent function look like for a cubic function. So remember, a parent function is when they don't have all of these extra values onto it. So for example, like just the cube. So ax cubed. Remember, the a still does the same thing as it's done on any other thing that we've graphed. The a tells us if the graph is going to open up or down, if it stretches, if it compresses, things like that. So if I want to graph a cubic function, I'm going to go ahead and just make a table of values. Okay. Anytime you want to know what a function looks like, make a table and then just pick lots of points. So I'm going to start off, as far as my x is, picking out a 0. And then I'm going to pick some positive numbers, and then I'm going to pick some negative numbers. All right, and so if I plug in this into my parent function, all right, let's go ahead and assume that the a is just going to be 1. So we're going to say that the a is just going to be a 1, so that I've got just an x cubed. Well, if I plug in negative 2 and I cube it, so negative 2 to the third power is negative 8. If I plug in negative 1 and I cube it, that gives me a value of negative 1. 0 cubed is going to give us 0. 1 cubed is going to give us 1. And 2 cubed is going to give us 8. All right, so let's go ahead and plot that. So I have a point at 0, 0. I have a point at 1, 1. I have a point at negative 1, negative 1. Okay, so right now that looks linear, but we know it's not linear because it's going to be a cubic, so it can't be the same shape, which is where these other 2 points tell us what's going to happen. So we go with 2, 8. So that one bends up. And then I go negative 2, negative 8. All right, so I'm going to go ahead. It does have a curve. Okay, so it is not a straight line. And I could obviously keep picking more points, but because we're cubing, your numbers are going to grow quickly. But this is our basic direction for a cubic function. It goes through 0, 0. I've got these 2 symmetrical points. Okay, so 1, 1. I got negative 1, negative 1. Then my next point, it starts to like kind of skyrocket in both directions. All right, so that point right there, kind of how it was coming from the negatives, and then it turns and then it switches direction and goes up. We're going to call that the point of symmetry. Okay, and we'll make that like our starting point in later on lessons. Now let's talk about domain and range. Domain and range, it's been covered before in lesson 1.1. You might want to review lesson 1.1, domain and range, where we talked about interval notation, set notation, and inequality notation. But remember, the domain is you describing to the reader the x values. Okay, so what are our x's doing? All right, so is this graph always going to move to the right? So will this graph keep growing to the right? Yes. If I want to talk about the x values going this way, that graph will still always kind of move to the left as it goes down. So the domain, I can say, is from negative infinity to positive infinity. I chose an equality notation. You could do set notation, interval notation, either one. Now the range is you describing the y values. All right, so what's happening to the graph? Are the y values going to go up forever? Yes. Are the y values going to go down forever? Yes. So I'm going to say that the y values are between infinity, meaning it's going up forever, and negative infinity, meaning it's going down forever. Now, end behavior. You're describing to the reader, again, what's happening to this end and what's happening to this end. We don't really care about the middle. So we're going to say, as our x's approach positive infinity, and what that means is just as you go to the right on the graph, the y values, which are called the f of x, which way are the y values going? So as my x's go to the right, the graph goes up to positive infinity. Now I'm going to say as the x's go to negative infinity, which just means as we move to the left of the graph, which way is that end going? It's going down towards negative infinity. Okay. All right. Now, just like a quadratic function, cubic functions can be written in different forms as well. So for example, if we look at a cubic function where it's in the form y equals a times the quantity x minus h cubed plus k, this looks really similar to vertex form of a quadratic. The only thing that's different is it's a cubic instead of a quadratic. But it still has the same characteristics. So remember that the a tells you if the graph opens up or down. Oops, see, I'm used to writing quadratics. All right, so this tells you if the graph opens up or down. And again, we've talked about all of this before in lesson 2.1. Okay, so 2.1 we started talking about characteristics of graph. So I hit that more in depth, so you might want to review if you're not hanging with me in this description. All right, so remember that the h, first of all, you always have to change its sign. But that shifts the parent function left or right. And then the k is how it shifts the parent function up or down. All right, so here's the original parent function with all of these parameters, okay, which just means numbers. I can, for example, I can stretch this, I can make it narrower, I can compress it, which means I'm kind of like flattening it out. I can shift this left or right, or I could shift it up or down, or I could do a combination of all of those. So let's take a look at this example. Okay, so we want to describe the transformations given the equation. Let's say I have y equals 2 times the quantity x minus 1 cubed minus 4. All right, so number one thing that I can state is since the a is positive, that tells me two things, all right? Since it's positive, that means that the graph opens up. And since 2 is bigger than 1, okay, that means that they are stretching it by a factor of 2. All right. Next thing that I can talk about is the h. So remember, change the sign. So since the h is negative 1, we're going to change it to positive 1. So this tells me that they are going to shift it right 1 unit. Okay. And then 3, we're going to say what our k is. Here's our k. K does not need a sign change. So since the k is -4, that's going to shift the parent function 4 units. All right, so what they are doing to this graph is they're stretching it, so they're making it narrower, and then they are going to shift it 1 unit and then down 4 units, okay? But we'll get into graphing on the next example. Right now I just want to talk about us describing the transformations. Okay, let's try another example. Okay, so I have y equals, let's say, -1/4 times the quantity x minus, actually let's go x plus 5 cubit plus 1. Okay, so again, the A tells you 2 things. So since our A is negative, okay, the graph opens down. Okay, since the 1/4 is less than 1, okay, that means that it is being compressed by a factor of 1/4. Also, remember that if you don't like compressed, you can say that it is widened. If you don't like the word stretched, you can use narrowed. Again, that was in that lesson 2.1 where we talked about that information. All right, number 2, let's identify what our h is. So again, do a sign change. So h is -5, so that means they are shifting the parent function left 5 units. And then third, we're going to identify the k. No sign change, so because the k is 1, they are shifting the parent function up 1 unit. Okay, let's look at some examples where they give you the description and you write the cubic function. All right, so I wanted to just put some key things on here for 2.1. Again, stretching means that they are narrowing the graph. If they say a compression, that means that the graph is widening. This is all a descriptor for your A. Okay. If they say that we have been reflected across the x-axis, that means that the A is negative. All right, so in this example, we're going to write the equation of the transformed function. All right, so I've written down some descriptions where we're going to write the equation of the transformed function. They tell us that the graph of f of x equals x cubed, and it's stretched by a factor of 4, reflected across the x-axis. It's shifted left 6 units, and it's shifted down 5 units. All right, so anytime that they talk about stretched or a reflection, that's all of your A information. Okay, so this is all about A. If they talk about shifting left, this is your H. And if they talk about shifting up or down, that's your K information. All right, so the K sign never changes. So our K is 5 units. H, however, is always a sign change. All right, so we'll deal with that more in just a minute. But if they say left 6 units, that means right now it's a -6, but we'll have to change that later. And then when they're talking about A being stretched by a factor of 4, okay, and it's reflected across the x-axis, that just means it's negative. All right, so there's my information. We're going to put it all together. So we're going to say y equals our A. There's the reflection across the x-axis. There's the stretch factor. This is just kind of like the same thing as slope. The slope is 4. Okay, so we're going to say negative 4 times the quantity x. Do your sign change now from negative 6 to positive 6. Make sure you remember it's a cubic. And then we have our plus 5. Okay, so there's our equation. All right, let's look at the next one. They say the graph of the function, the parent function, is compressed by a factor of 1/2. Okay, so a compression, again, is talking about your A. And then they're talking about shifting right. So that's going to be a descriptor of our H. All right, so we're going to say y equals our A is compressed by a factor of 1/2. We're going to say x. Now, if our H is 7, remember you're going to do a sign change. And this is a cubic function. They don't tell me that we're going up or down any, so I don't need to worry about the K. All right. Also, when it's in this form and we get into graphing, we can make a table, or we can just figure out like where is that point of symmetry going to be. So those are going to be the next examples where we practice graphing. When it's in this function, it's going to be very similar to when we were graphing quadratics and vertex form. Okay, so we're first going to find the point of symmetry, which is going to be the HK. Because this is not a perfect reflection like a quadratic was, we are actually going to pick 2 x values higher and lower than this h value. Okay, and then we'll calculate the y values like we always do by plugging in our chosen x's. All right, so here's my example. Let's say I want to graph y equals -1 times the quantity x plus 1 cubed minus 2. All right, so first thing I'm going to go ahead and just make a table. All right, my h and my k, I'm going to put in the center of my table, so I'm going to change my h and I'm going to keep my k. All right, so that's my turning point, or not, let's say the point of symmetry. All right, so now I'm going to pick 2 numbers up. All right, so I'm going to pick -1. I'm going to count up to 0 and 1. I'm going to count down 2 units to -2 and -3. And remember, to find your y values, you're just going to plug your x into this equation. So we're going to say -1 times the quantity, -3 plus 1 cubed minus 2. Then I'm going to plug in -2. And then I'm going to plug in 0. And then I'm going to plug in 1. You can use your calculators. You can do order of operations. So here's -2 cubed. That's -8 times -1 is 8. 8 minus 2 is 6. Okay, this gives me -1 cubed is -1 times -1 is 1 minus 2 is -1. Okay, 0 plus 1 is 1. 1 cubed is 1 times -1 is -1 minus 2 is -3. Okay, so now I've got 2 cubed is 8 times -1 is -8 minus 2 is -10. If any of these values go beyond 10, you can still list them, but don't worry about graphing them. Okay, so if it's over a 10, we're not going to worry about it. All right, so we're going to plot the point of symmetry, which is at -1, -2. Okay, I'm going to plot 0, -3. I'm going to plot 1, -10, -2, -1, and then -3, 6. Okay. And remember, it's a curve. And there would be my graph. Okay. Also, I want to state my domain and range. So if I want to look at the domain of this function, okay, which is, again, the domain is you talking like, what is this graph doing left and right? Is this graph going to always kind of continue in a right direction? Is it going to always keep going to the right? Yes. Okay, it's kind of going right and down. But I'm only worrying about the left and right for domain. Is this graph going to always kind of keep going to the left? Yes. So the domain is negative infinity to positive infinity. The range is you describing the y values. Is this graph going to go up forever? Yes. Is this graph going to go down forever? Yes. So the y values will go to infinity and negative infinity. Okay, so this is inequality notation. Remember, interval notation would look like this. You guys could also use that notation. Little side note to you, domain and range for cubic functions will always be real numbers, okay, if you just want to remember that. Okay, let's try one more example where we're graphing. Okay, let's say we have y equals, and we have 2 times the quantity x minus 2 cubed. Okay, so again, first thing that I want to do is I want to make my table. I'm going to go ahead and write my h and my k, so sign change the h, so that point of symmetry is going to be at 2, 0. Okay, I'm going to pick 2 numbers up, 3, 4, and 2 numbers down, 1 and 0. And I'm going to calculate the y values by plugging them in. So I'm going to take 2 times 0 minus 2 cubed. So there's negative 8 times 2. That gives me a negative 16. So I'm not going to graph it, but at least I have it plotted. Okay, or I've got it just written down. So then I have 1 minus 2 cubed. So there's negative 1 cubed, which is negative 1 times 2 is negative 2. I already know the 2, 0. I'm going to plug in 3 minus 2 and then cube it. So there's 1 cubed is 1 times 2 is 2. And then I'm going to plug in the 4. So 4 minus 2, 2 cubed is 8. There's a 16, so I'm not going to graph that one either. But at least I have it. Okay, so we're going to go to 2, 0. That's our point of symmetry, or you can kind of think of it like that's where it is going to like change direction. So then I have a point at 1, negative 2, and then I have a point at 3, 2. Okay, be careful because some of you will make that a straight line. You need to remember that a cubic function has curves. So if you wanted to, you could roughly plot and say like, hey, my 416 is going to be like way up here. And my 0, negative 16 is going to be like way down here. So that way you can see that it's got a curve, but it's just going to be like super narrow. Do not make it a straight line, otherwise you'll get points taken off. Okay, now on this one I'm going to change it up on you. I'm going to say let's state the end behavior. Okay, so let's talk about this end. All right, so on that end, that's the right side of the graph. So as the x is going to the right, which is positive infinity, which direction is that going? That's going up. So the y values, also known as f of x's, are going up to positive infinity. And now you're going to talk to me about this end, which is the left side of the graph. So as the x is moved to the left, that's what this statement is saying, the y values are going down to negative infinity. Okay. And then the last type of example is they're going to give you the graph and they're going to say, let's write the equation. Okay. All right, so I'm going to go ahead and I'm going to plot negative 2, negative 2. I'm going to plot negative 1, 1. And then I'm going to plot negative 3, negative 5. Okay, so here's my cubic. There's one example, and then we're going to go ahead and just do another one. And I'm going to plot negative 3, negative 2. I'm going to plot 1, negative 1, and I'm going to plot 5, 0. Okay. All right, I misplotted. So the points I want you to plot, negative 3, negative 2, 1, negative 1, and 5, 0. So ignore that one. We're going to go 1, negative 1. So almost had it. All right, so looking at this, it's opening up, so I know the A is positive. If you know where your point of symmetry is. I'm going to just show you guys the fastest way of doing this. The A is like the slope. Okay, so I already know that this graph is going up, so the slope has to be positive. Okay, and I can actually count it, but it only works from the point of symmetry to the very next turning point. Okay, or not turning point, to the next point plotted. All right, so I have that it's going up 1, 2, 3, and over 1. Okay. This is still a 3 to 1 to the next point, but again, it's a positive graph, so that's why the A is negative. Now, this point of symmetry was at -2, -2. So that tells me my H and my K. So I'm going to say X, change my H, keep my K. All right. On this one, again, I can see that this is opening up. It's going in a positive direction, so the A is positive. Okay, here's my point of symmetry. Okay, it's kind of like where it changes direction. And then I'm going to find the slope. So I'm going to go up 1 over 1, 2, 3, 4. Up 1 over 4. This is my H. This is my K. So I'm going to change my H. I'm going to keep my K. This is the fastest way to write the equation. If that doesn't work for you, I'll show you guys another way maybe tomorrow.